What's going on, guys? Today we're going to be doing graphing of exponential functions. We'll get to logs in another lesson, but today we're just going to be graphing these guys, doing the transformations, all that stuff. Let's start off with the definition. We have a, we have b, we have x. It's basically any number being raised to a power other than 0. B being something other than 1, because that 1 to whatever power is still 1. So that's why we have a couple of restrictions on what that is. Anyway, so our first equation, y equals 2 to the x. This would be 2 to the negative second, which is 1 over 2 squared, which is, we know that is 1/4. Same thing, 2 to the negative 1. This would be 1 over 2, which is, well, we know that's 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And 2 to the third power is 8. So our graph, we have 3, 8, 2, 4, 1, 2, 0, 1, looks something like, oh, I missed. Hopefully you'll do better. Something kind of like that. So our domain, if you look, and I put this in the calculator as well, if you look here, I got this keeps on going forever, this keeps on going forever, it gets really, really close to 0, but doesn't quite touch it. But nonetheless, I can do any x values. So my domain is negative infinity to positive infinity, or all real numbers. My range, though, gets really, really close to 0, doesn't quite touch it, so that means I got a parenthesis 0, and then it keeps on going forever and ever and ever. Alright, the next thing is all this gobbledygook stuff here. Basically, the important stuff. I know this is a lot to take in, so go ahead and pause it and I'll talk. Okay, so growth, if you have something like b being raised to a power and it's a whole number, that means the graph is going to go up. It's a growth. Decay would be a fraction being raised to a power, and that would look something like this. All this other stuff is just all the same rules that we've been going over before, with one little difference. So h goes to the right, goes to the left. K, up, down. Negative in front, flips. The last thing, though, if we have a being greater than 1, it's actually a compression. And if it's between 0 and 1, it's a stretch. That's a little opposite of what we're doing here, and that's just dealing with exponents and multiplying and all that stuff. Okay? Let's do a couple examples. It'll be quick, no big deal. All right, so my first one, it's got a whole number, so that means it's growth. And -4 means it goes to the right 4 units. So that just means that everything's moved over 4. So instead of being at 3, 8, so my first point on my original graph, 3, 8, now it's going to be at 7, 8. My next one, instead of being at 2, 4, now it's going to be at 6, 4. So it still has a general shape, still kind of looks the same. It's just moved over 4 units. So my domain doesn't matter, it's still negative infinity to positive infinity. My range didn't change at all either, so it's still 0 to infinity. That was kind of an easy one. Number 3 here. Still got a whole number being raised to a power, still a growth. My transformations, it went down 2. So now I still have my normal shape, just everything is down 2. So let's see if we can do a general idea of what this looks like. Alright, so the domain didn't change at all. And by the way, you can put all this in the calculator and get a great picture. This is just a rough sketch. And my range, this time I'm getting really close to 2. If you look on your graph, on your calculator, it gets really, really, really close to 2, but doesn't quite touch it. So that would mean our range is -2 to infinity. Okay? Number 4, same thing, just going to list the transformations here. The 5 doesn't change anything, just changes the number that we're taking to the x power. Still a growth, transformations went left 3 and up 1, and I'll let you do the picture and domain and range. Number 5, though, got a couple of good ones here. First of all, it's a decay. That's our first decay problem because of the 1/2. Next one is that it went up 5, and then my negative sign is that it flipped across that x-axis. So what I would recommend doing is putting this in your calculator, and just be careful, just be cautious with all your signs and all that stuff. Oops, not what I meant to grab. There we go. So we got the, so I would do negative and then in parentheses 0.5, and then not 0.2, 0.5 to the x, and then plus 5. I'm going to change that to a 0.5. sure everything's cool. Yeah, sweet. So when I graph this guy, the negative flips everything, remember? So it's going to be upside down. The 5 still raises it up 5, so it looks like this. All right? So let me go back. So kind of looks like this. I think it's really, really close to 5. Doesn't quite touch it. So my domain is still negative infinity to positive infinity. And by the way, the reason why I can do all real numbers for the domain is because no matter what number I plug in, I can get a value out. But my range is going to be from negative infinity to positive 5. It can get really close to 5, but can't quite touch it. All right, last two here. Go ahead and try those by yourself, and then I'm going to give you the answers. Here's your chance to pause. All right, let's look for those answers. Backwards here. There we go. So right 2, up 1, and then it flips. Range, or excuse me, domain is all real numbers, negative infinity to positive infinity, and then my range is negative infinity to positive 1 because it flips upside down. That's what that does. And so normally the graph would look something like this, but since it flipped, it probably looks something like this. And kind of the same idea for number 7 as well. It flipped down 2, left 4, and then also a stretch, negative infinity to positive infinity for domain, range negative infinity to negative 2. Okay, good luck, y'all. Catch you later. Bye.